Hello friends, good morning. In my last few lectures, I had explained about the important terms related with the protection of transmission line against direct lightning strokes. I had discussed pre-discharge current, isochronic level, back flashover, shielding angle, tower footing resistance, and coupling factor. Out of these six terms, the most important is the tower footing resistance because this tower footing resistance, if it is high, may lead to back flashover. If it is reduced, we can avoid the back flashover. Therefore, the tower footing resistance has special significance. Now let us see how this affects the magnitude of voltage to which the tower top is subjected with respect to the true ground during direct lightning stroke. I had given you this expression for computing the tower top voltage during direct lightning stroke with respect to the true ground. We denote this by Vm. The expression is RT, where RT is tower footing resistance. IL, IL is lightning discharge current. We also call this as stroke current. L is the inductance of the tower. RT is tower footing resistance, that is resistance of the tower. DIL by dt is rate of rise of stroke current. Now first I will give some statistical figures, then we compute Vm. RT, that is tower footing resistance, is in the range of 10 ohms to 30 ohms. L, inductance of the tower is very small, that is in the range of 10 microhenries. IL, that is stroke current, is 30 kiloamperes. Now let us see how to compute this factor. I had explained you that the lightning stroke or lightning voltage has impulse nature. Impulse nature means sharp rise in magnitude and relatively slow decaying. So here, as per Indian standard, this voltage reaches to peak value from 0 in 1.2 microseconds. And peak value of this lightning stroke current is 30 kiloamperes. So DIL by dt will be 30 and this time. So 30 divided by 1.2 into 10 to the power minus 6. So this will be kiloamperes per microseconds. If we remove this 10 to the power minus 6, then it will be 25 kiloamperes per microseconds. So this is the rate of rise of stroke current. These three are also statically obtained figures. Average height of the cloud we take for computation purpose as 1500 meters. Average speed of pilot leader or pilot steamer, that is the channel which starts from the cloud towards the earth, has average speed of 0.15 meters per second. Therefore, the time required to reach this pilot leader or pilot steamer to the earth from the cloud is 10 milliseconds. Now let us compute this tower top voltage, that is Vm, with tower footing resistance value of 30 ohms. So Vm, use this formula, substitute the values RT 30 ohms, IL 30 kiloamperes plus L 10 microhenries into DIL by dt 30 upon 1.2 into 10 to the power minus 6. So with this, this comes out 1150 kV. Out of this 1150 kV, this component is 900 kV and this component is 250 kV. And this will remain constant because we are not changing the resistance. We are not changing the inductance. We can control the tower footing resistance by some means. And you can see here the major contribution is due to this RT 900 kV and it is just 250 kV. So approximately 1/4 or 1/3 or 1/3 to 1/4 of this value. So it is 1150 kV. Now if we reduce this tower footing resistance by some means to let us say 10 ohms, then computed value will be 10 into 30. So this component will reduce to 30 kV, sorry 300 kV from 900 kV. This will remain as it is, that is 250 kV. So Vm is coming 550 kV. Now you can compare the value of voltage to which tower top is subjected during direct lightning stroke with tower footing resistance of 30 ohms and with tower footing resistance of 10 ohms. It is 1150 kV and it is 550 kV, almost half. So if we reduce tower footing resistance, then we avoid the possibility of back flashover, because this VM is responsible for the back flashover. Now let us see what are the methods for reducing the tower footing resistance. Now let us see the methods to reduce the tower footing resistance. There are two methods. One is by using the ground rods and second is by using the counterpoise wires. First, ground rods. These are the rods buried in the ground and connected to the tower below the ground. Number of ground rods and their dimension depends on how much tower footing resistance we want to reduce. Next is counterpoise wire. These are the wires buried under the ground and they are running parallel to the transmission line and they are connected to the towers. With the help of diagram, I will try to explain this. This is earth or ground. These are the towers. These are the conductors. This is inside this ground. So we are using the ground rods and these ground rods are connected to the tower. Now suppose this is the part of the tower under the ground, then ground rods are like this. They are surrounding at regular intervals to this tower and they are connected to the tower. Then counterpoise wires are the wires. They are running parallel to the conductors or transmission line inside the ground and they are connected at regular intervals to the towers. Again, number of these counterpoise wires are decided by the criteria how much tower footing resistance we want to reduce. So by using the ground conductors and ground rods and counterpoise wires, we can reduce the tower footing resistance. And you have seen just now what is the effect of reducing the tower footing resistance. The magnitude of tower top voltage will reduce and this will avoid the possibility of back flashover. So friends, if you feel this video lecture useful, then please like it, subscribe to my channel, ask your friends, colleagues, your juniors to subscribe to this channel for upcoming lectures on high voltage engineering and power system protection. If you want to make efficient and effective use of time, then read my book on time management. The link for the book is given in the description box. I have launched a useful course for students on UDEMY. The title of the course is Boost Your Learning and Become Top Achiever. This course is very beneficial for the students who are appearing for the competitive and entrance exam. The link for the course is also given in the description box. Thank you.